Good morning. We're the team behind Prism. I'm Fabian, and I'm joined by Ashley, Kai, and John. We're here to talk about unlocking the world's most valuable data. We live in a paradox. We have more data than ever in healthcare, finance, and government, but we can't use it. Billions in insights are locked away because companies can share sensitive data. Why? Because compliance kills collaboration. Legal review takes 6 to 12 months, trust is expensive, clean rooms cost over $100,000, and you still have to trust a third party. And comparative risk means sharing data might reveal your business secrets. The current solution is manual anonymization. It's slow, expensive, and often fails. We need a better way. That's why we built Prism. Prism is a privacy preserving analytics platform. It allows you to run standard SQL queries on sensitive data without ever needing to see data rows. It acts as a secure shield. You ask a question, and Prism gives you the answer, mathematically guaranteed to protect individual privacy. Here's how it works in three simple steps. First, you upload your encrypted datasets. Second, you query them using standard SQL, no new language to learn. And third, you receive a privacy safe insight. You get the aggregates you need, but the raw data never leaves the secure environment. Next, Guy will talk about the differentiators of our product.
Okay, Prism is built for the real world. Most of the competitors force you into a single privacy model, like only using MPC, which is slow, or only using enclaves, which requires hardware trust. Prism is different. We use adaptive privacy backend selection. Our system analyzes our query and routes it. Simple stats go to our differential privacy sandbox. Complex joins go into MPC. Is it 10 to 100 times faster because we match the tool to the job. But speed isn't enough. You need safety. This is why we build composable budget tracking. In privacy, every question you ask leaks a tiny bit of information. We track that leakage or epsilon across every single query. If a user tries to run a query that would exceed their budget and risk exposing someone's identity, Prism automatically blocks it. And finally, you need trust. We generate cryptographic proofs for every transaction, zero knowledge proofs, neutron attestations. It's artifacts that proves the data stays private. We need just say it's private. We don't just say it's private. We prove it mathematically. And the market for this is huge. Privacy-enhancing technologies are projected to be like 25 billion industry by 2030. We are targeting sectors where the pain is the highest: healthcare and finance. They are desperate for a solution that balances the utility and the compliance.
So as you know, Prism, we are a B2B SaaS company, and we charge based on data volume and privacy complexity. And we have a tiered model, starter for small teams, which is for like basic DP queries, and enterprise for large organizations who need on-premise deployment. So where are we today? For our product, we built a fully functional MVP. We have the Rails app, the user authentication, and the core differential privacy engine working. If we were to take this forward as a real startup, our next steps would be integrating multi-party computation to allow cross-organization joins and eventually adding homomorphic encryption. We believe we've built a solid foundation for the future of privacy.
Okay, thank you. Oh, actually, there's more.
Yeah. Oh. And to summarize, Prism breaks down data silos without breaking privacy. And now to show you exactly how it works, I'll hand it over to Ashley for a live demo.
Fire. Okay, cool. So, um, Hey guys. Okay, so we had our video got cut short, so we have to redo the demo, but that is okay. I'll just like attach it to the end. I'm gonna share my screen. I'm gonna share my. There you go. Sure. Cool. Okay, so moving on to here, I'm gonna remove this from here. Okay, so I'm going to show you how Prism allows organizations to collaborate on sensitive data without sharing raw data with each other. And this is very important in lots of industries, like how it was mentioned before, where privacy regulations are super important. So before we get into it, I'm going to give a little explanation of like a differential privacy with an analogy. So imagine you're in a room with 1,000 people, and I ask how many of you have 20/20 vision. Everyone who has it will raise their hand, and I will say count to 137 people. But say you specifically leave the room, and I ask again, and this time I count to 36 hands. So by comparing the two counts, I learned your private medical information with certainty. And this is what we call like a differencing attack. And this is what differential privacy protects against. So it adds carefully calibrated random noise to the results. So instead of getting like maybe 237, I would get 241 or 233. And that noise is small enough where I still get like significant and useful results, but it's large enough where I can't tell if it's a single person, like I can't tell a single contribution to the data set. And this is controlled by a parameter called epsilon, which is the privacy budget. And you can kind of think of like a bank account where every query costs some epsilon, and once spent, you can't query that data anymore without risking privacy. So budget automatically. You can't accidentally query compromise. And the system blocks you from making any more queries. This is composition theorem. It ensures that even multiple queries can't be pieced together like a puzzle to leak information. So I'm going to show you how this works in practice. I'm going to log in here as Alice. Should have password 1, 2, 3. So I'm logging in as Alice Johnson, who is a data analyst at City General Hospital, and Alice wants to analyze her hospital's patient treatment costs. And so it's, I guess in medical fields, it's also important to have that sort of internal query privacy protection. So this is really cool for that. So I'm going to go into the data sets really quick to show you guys how you guys can make a data set. So say I want to upload employee data, I can just upload a CSV file and we do all like the processing. So you get like these columns. This organization is weird. But anyways, you have like a budget, and so far we haven't ran any queries on it. So we have consumed 0 epsilon, and yeah. But to do like the queries, I'm just going to use this data set that was already like pre-fed into it to my seeded data. So let's run a query. Oh, also like note like a couple of different things. So this one has 15,000 rows. The other data set that I uploaded had 30,000 rows, which is like, this is nicer to work with because you can run more queries. And yeah. So I'm trying to compute the average treatment cost. And in a traditional database, this would return the exact average, but we're going to look and see what Prism does. So hopefully my SQL isn't horrible. Treatment cost from, I think, hospital patients. Okay, and you can kind of see as I was typing how this was validating that query, and we have an estimated privacy cost of 0.5 epsilon. For user, we have this little thing, just guide to help them see what kind of queries they can run. But let's create this query, right? So this query was created successfully because it was deemed as like safe, and we can execute it. So let's execute. And it was completed. So here we can see that it gave us this average of 2,584. But this isn't actually the actual average. This is actually with the noise added into it. So over here, I added this for like demo purposes. But you can see how the actual true average was 2,606. So it's a little like different. It's a little off. But again, that was done like on purpose in line with like differential privacy. Yes, and a couple of details, more details. You can kind of, we are very transparent about what mechanism was used because we have 3 different backends. I think as was described in the pitch deck. And this was Laplace, which is the algorithm that added the actual noise based on epsilon and sensitivity. Sensitivity. There's like a couple of details here, but I mean, it's just like a lot. Yeah. But a couple of key ones that I do want to mention is delta, which is the failure probability, and it's a chance that privacy could theoretically be violated, and also sensitivity, which, where is it here? I can't find it. But basically, sensitivity, it measures like if I add or remove one person from the data set, how much can the result change? So it's pretty useful for someone who just wants that full transparency. I'm still kind of figuring out what a person would need for it to be like transparent enough, but also like obviously you shouldn't know what like the noisy versus the true count is. Yeah. And we go back to the data sets, you see that this depleted the budget a little bit. I don't know if you guys caught note of how much it was before, but theoretically, if I just keep running queries, it's going to run out and it's just going to block me from making any queries. But yeah, it's going to take a while, so we're just not going to do that. So far we've seen how one organization can query its own data with privacy protection. But what about collaboration between organizations? So Alice's hospital has 15,000 patients and Memorial Medicine has 12,000. Together, that's 27,000 patients, and it's enough to do more statistically significant research than one hospital alone. But they can't share raw data because HIPAA forbids it. So they need a way to compute aggregate statistics across all 3 hospitals without any hospital seeing another patient's records. And this is where like MPC or multi-party computation comes in. And I'm going to show you how that goes. So I'm going to go into data rooms. So it's just like a space where organizations can jointly execute a query. So I'm going to make a data room as Alice. Let me see my time. Yeah. I think I can just average. You do want a description because again, it just helps with transparency. Okay, and then okay. I'm going to create this data room, and here we have this. I'm going to invite an organization. Here I have some preceded data, and I'm going to invite Memorial Medical Center. I'm going to send the invite. You can see this email that I have. I just kind of put it here for the demo purposes, but you kind of have to like, I'm going to log in as Bob. And just have that page show up. I have a lot of like information here, but basically it's just all the information lets me know the query type and who invited me, and the data set that I would like to contribute, which is my Memorial patient database. And I would accept this invitation or decline it. Oh, I guess it was already processed. I don't know. So I'm going to go into this data room and I think I have to, interesting. Low-key a work in progress, but ideally it would be attested and everyone can run this query. Once you, by the way, like when making the data room, you have, and like this with this query text, you can't change that, and it's just done so that everyone has informed consent on like what kind of query they're running on what data. So yeah, and that's basically it, I think. But yeah, thank you for looking at our stuff.